Welcome back to another Daishinfinity video. In this video, we're going to talk about a new topic, which is set theory. Set theory is a branch of mathematics that concentrates on sets, where a lot of mathematical objects are placed inside. Now, in this video, I would like to talk about three lemmas or three kind of informations that we can get from an empty set. So I would like to prove those three to you guys in this video. So let's just dive right in. I would like to first of all explain what a empty set is. So an empty set can also be written as a bracket where the bracket inside the bracket there's nothing inside. This is literally like the definition of an empty set. So in an empty set, there's nothing inside. So if we look at the cardinality of the empty set, I'm just going to write it again. Then it will be 0 since there are no objects inside. If we look at the set A, let's take, for example, 1, 2, 3. Then the cardinality of A is equal to 3 since there are 3 objects in the set A. So if we look at A and the empty set, we can say that for every A, that the empty set is always a subset of A. For all A that is existing in our mathematical world. So in order to prove this, I would like to show you guys and introduce you guys a set. Let a set B be a subset of A. This means, or this implicates, that for all B, for all X, so for all elements in B, which is called X, I'm just going to call it X, which is in B, implies that X is also in A, not in B, in A. Okay? Now, if this is true, then B is a subset of A. Or if B is a subset of A, this is also true. That's why it's equivalent to saying this. Okay? Now let the set B just be equal to the empty set. Then there exists no X in an empty set since the cardinality of the empty set is 0. Okay? Since nothing is inside, no objects can probably or like by any chance be inside this empty set. And that is why there is no clue that anything can be inside the empty set. Okay? Now, if anything can be inside the empty set, then we cannot say that every empty set is a subset of A. But since there's nothing, and since A is a set of numbers or anything, let's just call it A1, A2, and so on. And if even A is an empty set, which is this set, then the empty set will also be a subset of A since the empty set is A, which is the empty set. Okay? So it can either be the same thing or it can be a subset of it. So we have just proven for the smallest set A that the empty set is still a subset of A. So for every A, it means that the empty set is a subset of A for all A. Okay, I hope you guys understand this. If you have any questions, just write them in the comments, okay? Good. Now let's try the second one. If I have an empty set and combine it with A, then it always comes out to be an empty set. Now, to prove this, let's just say let X be an element of the empty set and A. This would be equal to saying that X is in the empty set and X is in A. But if we talk about X being in the empty set, this can never be possible since nothing is in the empty set. So this is a contradiction, saying that nothing can be an empty no object can be in the empty set. Okay. So it implies actually that if we have an empty set and if we combine it with a set A, then since we came to a contradiction, we can only take the smallest set possible of those two sets that are given here. So it's the empty set. Okay. It's a bit tricky, but I hope you guys understand. Now the third one is if we have an empty set and combine it with A in this form, then we get A for every A. So let once and for all X be an element of the empty set and A, or A, I'm sorry. This would be equivalent to saying that X is an empty set. It is in the empty set, or X is an element of A. Now, if X is in the empty set, it is always not possible. But since we have this one, and since we have a or, as like a logical symbol, we can take this to be a true statement and this to be a false statement. But if we have a false or a true statement, then we have a true statement for every true statement that we have there. So X is in A, so we can imply that X is in A. So from saying the empty set or A, we can say A since every X is in A for all X in A. Okay, so I hope you guys enjoyed this video. Please like and subscribe, and if you like this video, please share it to some friends, and I hope you like it. So we'll see us in the next Daishinfinity video. See ya.